welcome back to YouTube Learning, BPSC Learn from Home. So in my previous video, I have told you about the general terms related to machines, is it not? So we have started machines chapter and we have learned some of the basic terms which are related with machines. Now, what is a machine? A machine is a device which is used as a force multiplier, as a speed multiplier. Force multiplier means what? Using less effort, you can lift very heavy loads. And speed multiplier means by moving the effort to a small distance, the load can be moved to a large distance. You can use a machine to change the direction of effort, is it not? Then you can use a machine to change the point of application of force. You can also use a machine to do some dangerous works which are not possible by human beings. And which are the terms we have learned? We have learned about the terms load, effort, is it not? Then mechanical advantage. Mechanical advantage is load by effort. Apart from that, we have learned about work input, work output, principle of a machine. Then velocity ratio, which is the ratio of velocity of effort to velocity of load. Then we have even learned about the efficiency of a machine, is it not? So all these things we have learned in our previous classes. Now let us come to an ideal machine and an actual machine. Ideal machine. Ideal machine means what? In an ideal machine, the parts of the machine will be frictionless and weightless. The parts of the machine will be frictionless and weightless. So, if you take any machine, usually we will not come up with those machines, such type of machines where parts will be frictionless and weightless. Always the parts of the machine have friction and there will be some weight for the parts of the machines. Is it not? But an ideal machine is such a machine where the parts will be frictionless. No friction will be there in between any two parts of the machine and the parts will be absolutely weightless. And inside in an ideal machine, the work output will be always equal to work input. Means how much input you are giving for the machine, the same amount of output is obtained. For example, if you give 100 units for a machine work, if you put 100 units as input, how much output you will get? You will get output. One more example if I want to give, suppose you have a petrol engine, like they will tell for 1 liter of petrol you will have some mileage of 40 to 50 kilometers. Understood? So every time you are pouring 1 liter of petrol into your petrol tank and every time you are getting the fullest output, 40 to 50 only, then what happens? The work output will be equal to work input. In such cases, what will be the efficiency of the machine? The efficiency will be 100%. Or you can tell unity. If the efficiency is 1, means work output by work input is equal to 1. 1 multiplied by 100 will be 100. Efficiency will come to be 100%. Such a machine is called an ideal machine. But actually speaking, in daily life, we will not come across ideal machines, we have only actual machines. Now one more thing, in an ideal machine, as I said, work output will be equal to work input, efficiency will be 100%. Understood? Here, mechanical advantage is called ideal mechanical advantage. For ideal machine, the mechanical advantage will be equal to or is called ideal mechanical advantage. Now when it come to actual machines, in actual machines there will be friction between the parts of the machinery and the parts of the machinery will be having some weight. In such cases, what happens? Work output will not be equal to work input. Understood? So, suppose if you give 100 units of work to the machine, all the 100 units will not be converted as output in that 60 units, 50 units or 70 units will be converted as output. So work output will not be equal to work input. Then what is happening? Some energy is being wasted, is it not? Some energy is being wasted. Means that energy will be converted into other forms of energy. The machine may get heated up. Some energy will dissipate into the surroundings. Something can happen. Some energy is lost due to friction between the parts of the machinery. Whenever there is friction, there will be heat energy developed, certainly. So the work output will not be equal to work input. In such cases, what happens to efficiency? Efficiency will be less than 100%. Right? Efficiency cannot be 100%, it will be less than 100%. So you can refer your textbook also. In that he has given what is ideal machine and also what is actual machine. So ideal machine means the weight of the machine will be negligible and there will be no friction between the parts of the machinery. But when it comes to actual machines, the efficiency will decrease. It will be less than 1 or less than 100%. Okay. Now here also mechanical advantage will be there. And that mechanical advantage is called as actual mechanical advantage. AMA means actual mechanical advantage. Here ideal machines, it is ideal mechanical advantage. Of course, when we solve the problems usually, you will have such problems where we are talking about ideal machines only. Means we are neglecting the weight of the machine and also we are neglecting the friction. So you need not break your head. Simple numerical problems, usually what they will have? They will have ideal machines only in picture. But sometimes we may solve problems on actual machines also, where we have to consider the actual friction and also weight. See, when mechanical advantage in case of actual machine changes means what? Load, here ideal machine, load will be equal to load only. If load is 100 kilogram force, then that much only will be the load which we are taking in ideal machine, because we are not at all bothered about the friction and also weight of the machine. But if you take actual mechanical advantage, then here in such cases, actual machines, load will not be equal to L. It will be equal to L is equal to L plus X. Now what is X? X can be the weight of the machine or it is due to the friction also. So the load value changes here. The load value changes in case of actual machine. Then load value changes, what happens to the mechanical advantage? Here L is equal to L, E is equal to E. In case of ideal machine, MA will be equal to L by E will be equal to L by E only. So L by E, L is 100, E is 100. What is the mechanical advantage? Mechanical advantage also will be equal to 1. But here you see mechanical advantage, here it will not be equal to 1. Load will be greater than effort. Load will be greater than effort. So here load will be equal to load plus weight of the machine. So naturally what happens? The mechanical advantage will change. That is called actual mechanical advantage. So this much you should know about ideal machine and actual machines. Okay. Next, there is a very important derivation which you have to learn in this chapter. That is the relationship between mechanical advantage, velocity ratio and efficiency. Relation between mechanical advantage, velocity ratio and efficiency of a machine. So this is a very important derivation. It is there in the syllabus also. You can just refer the further reduced syllabus. According to further reduced syllabus, you have to learn the relation between mechanical advantage, velocity ratio and efficiency. Now, mechanical advantage, we know it is L by E, right? And right here, mechanical advantage will be equal to L by E. Now, velocity ratio will be equal to how much? Velocity ratio will be equal to dE by dl, right? It is the ratio of velocities of effort to that of load, or you can express velocity ratio in terms of distances also, because velocity is nothing but distance by time taken. So it can be even expressed as a dE by dl, where dE is the displacement of the effort, dl is the displacement of the load. Now coming to work output, work input we shall take. Work input will be equal to how much? So even in your textbook also he has given the derivation, right? Work input is equal to work. What is the formula? It is force into displacement. That was our right. Force into displacement. Is it not? Now here if you take work input, in case of machine, what is the force applied on the machine called? The force applied on the machine is called the effort multiplied by displacement of the work. Effort multiplied by displacement of the work. So work input will be equal to E multiplied by dE. Likewise, work output will be equal to what is the work done by the machine for us? How much force we are getting? How much load we are able to lift? That is called load here. Again, F into D. F is nothing but force. How much load we are lifting? How much force we are overcoming? We are overcoming L amount of force. So work is again force into displacement. So it will be equal to L into dL. Right? Okay. Now let us take by definition. What do you get by the definition of efficiency? Efficiency, eta. Last class I told in last video that efficiency is denoted by the letter eta. Efficiency will be equal to what? Work output by work input, right? This implies efficiency is equal to what is work output? L into dL divided by work input will be equal to E into dE. E into dE. Now this is equal to L by E multiplied by dL by dE. Is it? I just written separately. This implies therefore efficiency will be equal to L by E is what? L by E is a mechanical advantage, right? L by E is mechanical advantage. Now dL by dE. dE by dL you know. dE by dL is velocity ratio. From this dL by dE will be equal to 1 by velocity ratio. Is it not? So it will be equal to 1 by velocity ratio. Therefore, efficiency is equal to mechanical advantage by velocity ratio. See, this is the relation between efficiency, mechanical advantage, and also velocity ratio. Understood? So, this is the derivation which you have to learn, and it is very important also. So, once again I will repeat, to derive the relation between mechanical advantage, velocity ratio and efficiency, what you have to take? You have to take the work input. Work is nothing but force into displacement. So input means I am applying effort and the effort is moved through a distance d, right? So E into dE. Likewise, work output will be equal to L into dL. Load is the we are able to lift the load, we are overcoming certain amount of force which is called L, and the load moves to a distance, that is dL. By definition of efficiency, eta is equal to work output by work input. Work output by work input. Therefore, efficiency is equal to L into dl by E into dE. So simplify, how much you will get? Efficiency is equal to mechanical advantage by velocity ratio. So this relation you have learned. Please note down the steps. Theta is equal to mechanical advantage by velocity ratio. Now for an ideal machine, what we have learned? Work output will be equal to work input. Work output will be equal to work input for an ideal machine. If both are equal, then what will be the efficiency? Efficiency will be equal to 1. In such cases, what happens? Mechanical advantage by velocity ratio will be equal to 1. Right? Both are same. E into dE by L into dl. E by E you can take, or L by L you can take. dE by dE or dl by dl. Just see here. L into dl, E into dE. So if both are equal, then instead of L you can write E, instead of dl you can write dE. Then what will be the output? The output is this much. This is the input. Then mechanical advantage will be equal to 1. Velocity ratio will be equal to 1. So the efficiency will be equal to 1. So always remember the ideal machine, mechanical advantage by velocity ratio is equal to 1. This implies mechanical advantage will be equal to velocity ratio. Understood? Now for an actual machine. For an actual machine means, practically speaking, what I have told you, output will not be equal to input. Output is always less than input due to friction and weight of the machines. So in such cases, output is less than input, right? Output is less than input. Then what happens? Efficiency will be less than 1. Efficiency will be less than 1. Mechanical advantage will be less than velocity ratio. So this is very important to remember. So in case of ideal machine, work output will be equal to work input, therefore efficiency will be equal to 1 unity. Mechanical advantage will be equal to velocity ratio. For an actual machine, output is less than input, so efficiency will be less than 1 and the mechanical advantage will be always less than velocity ratio. Why? Due to the weight and the friction of the machine. So this is all about the relation between these three quantities. In the next video, we shall learn about pulleys. According to further reduced syllabus, this concepts of lever is not there for examination. So we shall discuss about pulley. Pulleys, in that single fixed pulley, single movable pulley, and then block and tackle system of pulleys. Okay children, thank you very much. Please learn the derivation.